All right, folks. This is homework number 6 for chapter 1. Let's get going on this. Number 68. Use what you have learned about exponents to rewrite each of the expressions below. You could do this any number of ways. I'm going to do it with the rules that we learned, which is going to be equal to h to the 11 minus 9. And 11 minus 9 is 2, so the answer is going to be h to the second power. That's it. Next one, B. We're going to do it with what we just learned. X to the third times x to the fourth. This is going to be the product of powers. This is going to be x to the 3 plus 4. When you multiply exponents, you actually add. So 3 plus 4. So this gets you x to the 7th power. This one right here, I might not be too sure, right? So let's say, you know what? I don't know. Mr. Shaw hasn't really taught me much about this. So I'm going to do this like how we did it the other way, right? So it's going to be 3K, K, 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 K. That's what it means, that 3K to the 5th to the second power. Okay, so I expanded the 3K to the 5th. And then that means I actually have 2 of these. Let's move this over a little bit. Like that. So what happens? Well, I have a 3 and I have a 3. So I can put them back together. So the answer would be 9. And then how many K's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 9K to the 10th power. Okay. So I'm going to work that one because, maybe I'm not too experienced. Oh, but this one I can do, right? Because if it's n to the 7 times n, and there's one more n, which is actually an invisible 1, this is going to come out to be n to the 7 plus 1, which is actually n to the 8. Yep. Let me see. I think I can do this. I can do 16 divided by 2. I can work it like that. 16 divided by 2 is 8. I can write like 8, or I can write it as 8 over 1. Okay, either way, but I'm going to write it as 8. I'm going to figure out what x to the 4th divided by x to the 4th is. Right? And I'm going to use a quotient property. So I'm going to get x to the, and then x to the 4th divided by x to the 4th. So you're going to go 4 minus 4, which is actually 0, but I'll take care of that in a bit. And then you have the last piece, which is y to the second power. Okay. Becomes 8. X to the 4th is x to the 0. Right? X to the 4 minus 4 is 0. Y second. And we know x to the 0 power is going to be 1. So we get 8 times 1 times y to the second. 8 times 1 is just 8. So we get a final answer of 8 y to the second power. Okay, and the last one. This is a lot of work. So maybe I might just want to write it all out, like how I didn't like how we were doing for the last couple of days, writing equivalent expressions. So maybe I might just want to write this out as, I'll use orange, as 4 times x times y times y times y. That's one piece, and I'm going to multiply by another piece, 7 times x times x. Oh, out of space. Times y times y times y. Right, and then I'm going to go ahead and multiply this together, meaning put them together. So I got 4 and 7. Now it gives me 28. And then I got my x's. It looks like I got 1 here, and I got 2 here. So that means I have 3 of them. So x to the third. I'm going to put my y's together. I have 3 here. I have 3 here, which is 6. So it'll be y6. Okay. So you can do it any way you want. If you remember, you can do it with the rules. If you don't remember, it's okay. You can do it with the simplification of it through repeated multiplication. Okay. 69. Lacey and Haley are rewriting expressions in an equivalent simpler form. Haley simplified x to the third times x squared and got x to the fifth. Haley simplified x to the third plus x to the second and got the same result. However, the teacher told them that only one simplification was correct. Who simplified correctly, and how do you know? Okay, let's look. Okay, we'll put Haley in red. So x to the third times x to the second, and this is all multiplication. So it's really x times x times x. And then times x to the second is x times x. And together, that does make x to the fifth. So Haley is definitely correct. Okay, let's look at Lacey. X to the third plus x to the second. X to the third looks like this. X times x times x. And then the plus x to the second is x times x, right? And actually, because we're doing a plus, we're using addition. Okay, this is one term, and this is a second term. And with addition or subtraction, they have to be the same type of terms, and these are different terms. So if you have x to the third plus x to the second, you see that they're not the same type of terms. Your result is going to be x, x, x plus x, x, which is the same thing. It doesn't change. So x to the third plus x to the second makes x to the third plus x to the second. You can't do anything with that. So Lacey is wrong. Okay. So write down something. Second part. Haley simplifies 3 to the fifth times 4 to the fifth and got the result 12 to the 10th. But Lacey is not sure. Okay. So is Haley correct? Be sure to justify your answer. Okay. Well, we can work that out. 3 to the fifth is 3, 3, 3, 3, 3 times, and 4 to the fifth is 4, 4, 4, 4, 4. Okay. Now, do we get 12 to the 10? No. Does that equal 12, 12, 12, 12, 12, 12, 12, 12, 12, 12? I don't think so. Let me see. 3 times 4 is 12. So we got that. 3 times 4, those two, is 12. So we got that. 3 times 4 is 12. Got that. 3 times 4 at 12. And we'll go orange. 3 times 4 is 12. Right? So I took care of all of it, and I still have 12 more, or 10 more, or 5 more 12. So that is not correct. Okay. So 3 to the 5th times 4 to the 5th is actually, you know what that actually is? 3 to the 5th times 12 to 4 to the 5th is actually 12 to the 5th power. And that's not the same as 12 to the 10th power. Okay, that's not the same. You can cross that out. Because there's 12 and there's 5 of these. And then this right here gives you 12 and there's 10 of those. So, okay, so you got to write something. I'm not going to write it for you, but you got to write something down. All right, 71. If for a certain function f of x equals 9, find the following values. All right, so it's saying, you know what? If this is equal to 9, right, what would f... Oh, actually, sorry. Nope, that is wrong. It's saying, what is this equal to if the whole thing, f of x, you can replace it with 9. So we're saying, instead of f of x, we're going to put 9. So instead of f of x, we're going to put 9. So f of x plus 3, which is the same as 9 plus 3. See that? So f of x plus 3 is the same as 9 plus 3. And that makes 12. Again, f of x is 9. So the whole thing is 9. Not just the x, but the f of x. Like that. Okay? So, which means that we're going to be doing 2 times, and the f of x is 9. That gets you 18. Use a calculator if you have to. 2 times f of x plus 3. Oh, look, we already did that. Okay, so I can do it again. 2 and the f of x, that's going to be 9. Because that's what it says right here. F of x is 9. So f of x right there is 9. Plus 3. Okay, and 2 times 9 is 18. We did that on the previous problem. Plus 3, 21.